Hi guys, this week we are going to go ahead and look at something called matrix inverses. And the cool thing is once you know how to make the inverse of a matrix, it's going to give us another method for solving systems of equations. You will notice up here it says 4.5. We have actually gone out of our textbook and I'm adding in an idea about matrices that I think is really, really fun. So the 4.5 is because this is from a different textbook. Knowing that you will not be getting a book assignment with matrix inverses, it will just be worksheets. Okay, so we are going to go ahead and first talk about what an inverse is. And then our first skill will be if you are given two matrices, can you tell if they are inverses of one another, yes or no? Okay, and then some matrices do have inverses, others may not. So we have to figure out if a matrix has an inverse, and if it does, we're going to go ahead and be able to find that inverse. Because if you can find an inverse, then we'll be able to move on to the third, and this is actually our ultimate goal. How can you solve a system of equations using inverses? Okay, so what happens if two matrices are inverses of one another? And the notation that they use for the inverse, they include, it looks like an exponent with a -1. That indicates that it is an inverse matrix, okay? Now, there is something called an identity matrix. An identity matrix is that form that we got to when we were looking at Gauss-Jordan. So remember Gauss-Jordan, you had to get ones down what's called the main diagonal, and everything else had to be 0. This is called an identity matrix. And the reason why is because if you had it here, this would be your x value, this would be your y, this would be your z. So it's kind of cool. That was our way where we could go ahead and solve using Gauss-Jordan method. If you have a 2 by 2, remember you can still have what's called an identity matrix. It just means that you have your ones on the diagonal. Your other two values would have to be zeros. So the same thing on your main diagonal, you need ones. All the other values should be 0. So if they give you two matrices and they say, are these two inverses of one another? What you do is you multiply them. So if I take the original matrix times what they say is the inverse, you have to get an identity matrix, meaning at the end, if it's a 2 by 2, you need it to look like this. If it's a 3 by 3, you need it to look like this. And then you need to flip the two matrices around, multiply them the other way, and get the inverse as well. Okay, so if two matrices are inverses of one another, you can take the product, take the two matrices in whatever order you want to start with. You multiply them. Your solution should be an identity, meaning it's just the ones on the main diagonal and a 0. Then you flip the two matrices around. So whatever one came first now comes second, and vice versa. When you multiply them, you need to get the identity matrix again. If that happens, then yes, those two matrices are inverses of one another. So let's go ahead and try it, okay? Obviously, we are in an upper level math course. That's when you get two matrices. So you're going to see some fractions, but we are going to be just fine, okay? So in order to determine if these two matrices are inverses, let's just go ahead and multiply them the way that they are in this order, okay? So remember when you are multiplying matrices, I'm going to go ahead and just rewrite it because then I can write all over this and make sure you can still see. So -2/3, 5/12, 1/3, and -1/12. Okay, this is a 2 by 2. This is a 2 by 2. In order to multiply matrices, your two middle values have to match. They're both 2s. Your solution is going to be also a 2 by 2 because you find the dimensions by what you have left, the first number and the last number, okay? Now when I multiply matrices, it is the top row by the first column is going to get me that first row, first column number. So 1 times -2/3 is -2/3 plus, shift it over, shift it down. Now when I take 5 times 1/3, remember when you multiply fractions, it's top times top, bottom times bottom. 5 is the same thing as 5/1. So if I have 5/1 times 1/3, I would have 5/3. Now when you add fractions, you need a common denominator, which we have, so that's awesome. If I add the top, -2 plus 5 is a 3. 3/3 is a 1. So I do have the 1 there, okay? For the identity, remember, you need 1s in the main diagonal. If you would have got something other than a 1 right here, you could have said that they are not inverses and move on. Okay, but we got a 1, so now we need to see if this is a 0. So I stay with the top row, go to the second column. 1 times 5 over 12 is 5 over 12, plus 5 times negative 1 over 12, same thing. This 5 is over a 1, so it's like negative 5 over 12. Common denominator is a 12. Positive 5 plus a negative 5 is 0. 0 divided by 12 is 0. So far it's working. Okay, now I'm going to go ahead and look at the second row. I want the second row first column number. 4 times negative 2/3 is negative 8/3, plus 8 times 1/3 is 8/3. Negative 8 plus 8 is 0. My common denominator is a 3. 0 divided by 3 is a 0. So you guys, so far this is good. We're getting that identity. Now let's go ahead and get the last value that we need. It is second row by second column. So top times top, bottom times bottom. 4 times 5 is 20 over 1 times 12 is 12, plus shift it over, shift it down. This is negative 8 over 12. Common denominator is a 12, so that stays. 20 plus a negative 8 is 12. 12 over 12 is 1. Okay, so it did work this way. If I have this matrix first and this matrix second, when I multiply them, I get the identity matrix. You cannot say it's an inverse unless you can flip them around and get the same thing. So what that means is now I'm going to take negative 2/3 and 5/12, 1/3 and negative 1/12, and I have to multiply this first. 1, 5, 4, 8. That is going to be second. I have to get the identity matrix again in order to say it's an inverse. So you have to check both ways. You cannot say that they are inverses unless they both result in the identity matrix. So if I go top row, first column, 1 times negative 2/3 is negative 2/3, plus top times top, bottom times bottom. This would be 20 over 12. Now you can't add these because you need a common denominator, but I can divide the second fraction top and bottom by 4. So I'd have negative 2/3 plus 20 divided by 4 is 5. 12 divided by 4 is 3. My common denominator is a 3. Negative 2 plus 5 is 3. 3 over 3 is a 1. Now to get this value, it's first row, second column. Top times top, bottom times bottom. So this becomes negative 10 over 3 plus, shift it over, shift it down. This is 40 over 12. Now again, I can't add them like this because you need a common denominator. I can divide my second fraction by a 4 again. So I would have negative 10/3 plus 40 divided by 4 is 10. 12 divided by 4 is 3. I have my common denominator. It's a 3. Negative 10 plus 10 is a 0. 0 divided by 3 is 0. So far it's working. Okay, now let's go to the second row. First column. 1/3 times 1 is 1/3. Plus negative 1 over 12 times 4 is negative 4 over 12. Again, I have to simplify the second fraction. I can divide top and bottom by 4. So I have my 1/3 plus negative 4 divided by 4 is a negative 1. 12 divided by 4 is 3. My common denominator is a 3. Positive 1 plus a negative 1 is 0. 0 divided by 3 is 0. So as long as this ends up being a 1, we can say that yes, those two are inverses. Super cool. So last row, second column, 1/3 times 5, that's 5/3. Plus negative 1/12 times 8 is negative 8 over 12. I have to divide the second fraction by 4 to get my common denominator. Negative 8 divided by 4 is a negative 2. 12 divided by 4 is a 3. My common denominator is a 3. 5 plus a negative 2 is 3. 3 over 3 is a 1. This is the identity matrix. This was the identity matrix because you only have 1s in your main diagonal. The other values are 0. So the question says determine whether the two matrices are inverses. The answer is yes, because when you multiply them either direction, you end up with your identity matrix. Okay, same thing can happen if it is a 3 by 3 because the matrices that have inverses are our square matrices. So 2 by 2s, 3 by 3s, 4 by 4s. So we're going to go ahead and multiply. So again, in order for this to work, meaning that they're inverses, I need to be able to multiply them this way, and I would have 1s down the main diagonal. Everything else has to be 0. So it'd be 1, 0, 0, 0, 1, 0, 0, 0, 1, just like that Gauss-Jordan elimination we did. So if I start this, 1 times 1/2 is 1/2, plus, shift it over, shift it down. 0 times negative 1/2 is 0, plus, shift it over, shift it down. 1 times 1/2 is 1/2. 1/2 plus 0 is 1/2. 1/2 plus 1/2 is 1. Hey, so the first number worked. Now let's see if the second number works. 1 times 1/2 is 1/2. 0 times 1/2 is 0. 1 times negative 1/2 is negative 1/2. 1/2 plus 0 is 1/2. 1/2 plus a negative 1/2 is 0. So hey, so far. Okay, now let's try that third column. 1 times negative 1/2 is negative 1/2. 0 times 1/2 is 0. 1 times negative 1/2 is a negative 1/2. So when I add these, negative 1/2 plus 0 is negative 1/2. Negative 1/2 plus another negative 1/2 is a negative 1. So right now, we know these two matrices cannot be inverses of one another, because when I'm multiplying them this way, if I have a number other than a 0 here, that's not the identity matrix. The identity matrix can only have 1s in the main column. This would have had to have been a 0. Negative 1/2 plus negative 1/2 gives me a negative 1. So you can stop right there, because at this point you know you are not getting the identity matrix. They are not inverses. Turn page. Okay, so next skill, and this is the one that's going to help us learn how to do some decoding. At the end of this chapter, rather than having you do an exam, we are going to do a fun project. So if you look through your packet, you saw that. When you are decoding, one of the important skills is to create what's called an inverse. So here's the formula. If you are given a square matrix, and for us, we are going to deal with 2 by 2s. Okay, if you have a 2 by 2 matrix and you want to form the inverse, you have to take 1 over the determinant. So remember, when you are doing the determinant of a matrix, you take A times D, so you multiply diagonal, minus B times C. That is your determinant. So it's 1 over the determinant. Now what you're doing is rearranging this, because notice this is A, B, C, D. You're taking A and D. So the two values that are on the main diagonal, and they're changing locations. The D comes up here and the A goes down there. So these two values switch locations. Now notice the B and the C. They stay where they are, but you change their sign. So anything that was negative, you make it positive. Anything that was positive, you make it negative. Then you would go ahead and bring that determinant in. If you end up with a determinant of 0, that means you have no inverse, because the formula says 1 divided by the determinant. Well, if your determinant is 0, you can't take 1 divided by 0, because in math, that's one of those first rules that you learn. You can never divide by a 0. So that makes the whole process inadequate. So that just means it has no inverse, okay? We're going to go ahead and find some of these. So if this is my matrix and you want to find the inverse, step 1 is you have to figure out what is the determinant. So 4 times 1 is 4, minus 2 times 3 is 6. 4 minus 6 is a negative 2. So it's 1 over negative 2. Now what I have to do is take my 2 by 2, and remember the 2 on the main diagonal, they change spots. So the 1 is now in the upper left, and the 4 is now in the bottom right. So they just move. Now your 3 and your 2 stay where they are, but they change signs. These were both positive, so now I make them both negative. Now what I do is I multiply each by a negative 1/2, which is the same as giving it a denominator of negative 2. So here's my inverse. Negative 1/2 times 1 is negative 1/2. Negative times a negative is a positive. 1/2 times 3 is 3/2. Negative times a negative is a positive. 1/2 of 2 is 1. Negative times a positive is a negative. 1/2 of 4 is 2. There is your inverse. So it is just a formula. We're going to try a couple more because this is like the big skill for the day. Let's look at this one. Okay, so if I want to find the determinant, that's the first step. If you are going to find an inverse, determinant is your first stop. 4 times 1/4 is 1, minus negative times a negative is a positive. 1/3 of 3 is 1. Well, 1 minus 1 is 0. So if I have 1 over 0, this is undefined. You cannot divide by 0, so this matrix has no inverse. If you ever end up with a determinant of 0, that means this particular matrix does not have an inverse. You write no inverse and move on. Okay, let's look at the last one. Step 1, find the determinant. 3 times a negative 2 is a negative 6, minus 3 times 2 is 6. Negative 6 minus 6 is a negative 12, so it's 1 over negative 12. Now you take the values on your main diagonal and you change their location. So negative 2 comes up here and 3 comes down here. You keep this 2 and 3, but you change the sign. So this is negative 2, negative 3. Now what I'm doing is I'm giving everything a denominator of 12. If you multiply something by 1 over 12, that's the same thing as putting a 12 underneath all of these values. And in this case, it's a negative. Okay, so negative times a negative, that's a positive. 2 divided by 12, this is 1 over 6. Negative times a negative is a positive. If I put that 2 over the 12, 2 over 12 can be reduced to 1 over 6. Negative divided by a negative is a positive. 3 over 12 is 1/4. Positive times a negative, this one's going to be negative. 3 over 12 is 1/4. That is your inverse. Okay, so that's the second skill. There are 3 main ideas for the day. The first one, given 2 matrices, can you multiply them in both directions and see if they're inverses by looking at the product and making sure that you get the identity multiplying it both ways. If you get the identity, it's yes, otherwise it's no. The second skill is, can you take a 2 by 2 matrix, find its determinant, and use the formula to create the inverse? Now here's why inverses are cool. You can take a system of equations, okay, and you can rewrite it as what's called a matrix equation. So you start off with what's called the coefficient matrix. You take the numbers that are in front of the variables and you form a matrix. Then you have a variable matrix. The variable matrix only contains the letters that you are trying to solve for. Set it equal to the constant matrix. The constant matrix are the solutions to your original system. Okay, so here's what this actually looks like. We have spent this whole chapter trying to solve systems of equations. We looked at substitution method, elimination method, augmented matrices, Gauss-Jordan method, Kramer's rule, and now we're going to go ahead and use inverses. So it just gives us another tool for our toolbox. How can we solve systems of equations? Here is what's called a matrix equation. Again, your coefficients come first as their own matrix. Coefficients are numbers that come before variables. So you have to make sure your variables are lined up. So the x's are first and then the y's. So the numbers in front are 1, 1. That's how they got the 1, 1 here. The second equation, it's 2, 1. So you'll see it's 2, 1. Those are your coefficients. The variables that you are solving for are x and y. The x comes first in the equation. That's why the x is on the top. Equals your solutions, 8 over 1. Now, in order to solve this, what you have to do is isolate x over y. So if I want to take this matrix and move it to the other side, what I have to do is find the inverse. So you find the inverse of this matrix and multiply it in front of your solution. And then you would be solving for x and y. It's so cool. So here is exactly what I just explained, okay? So you go ahead and you have your matrix equation, your coefficients, your variables, and your solutions. You find the inverse of A. The inverse of A is your coefficient matrix. You multiply it to B. Notice it has to go in front. When you multiply inverses, you get your identity. So that's how technically this could cancel. It would just be your variables. In our case, it's going to be x and y. You just have to multiply the inverse of the coefficient matrix by your constants. Now here's just a little caution, something to remember. Matrix multiplication is not commutative. Commutative means you can multiply it in any order and get the same solution. It does not work with matrices. So it is important to multiply the inverse in the same order for both equations. The inverse has to come first. Your inverse has to come before your solutions. So let's go ahead and do a couple of these. You guys, this is kind of cool. I like this. So step one, you have to make a matrix equation. So you start off with your coefficients. The x's are lined up, the y's are lined up. So it's 2, 5, 5, negative 3. We are solving for the variables x, y. That is called your variable matrix. Now your constant matrix, those are your solutions, 0 and 31. This is a matrix equation. Your next step, you have to move this matrix to the other side. The way that you do that is you have to find the inverse. So to find the inverse, step one, you have to find the determinant. 2 times negative 3 is negative 6. Minus 5 times 5 is 25. Negative 6 minus 25 is negative 31. So your determinant is negative 31. So it's 1 over negative 31 outside of. Now you take these two values, they change their location. So the negative 3 is on the top and the 2 is on the bottom. The 5s stay where they are, but they both have to change their sign, so now they are both a negative. Now what I'm doing is I'm giving all of these terms a denominator of 31, and I have to make sure that I realize this is negative. So for this first value, negative times a negative is a positive. This is 3 over 31. Go to the second value. Negative times a negative is a positive. This is 5 over 31. Negative times a negative is a positive. This is 5 over 31. Negative times a positive is a negative. This is 2 over 31. Here is your inverse. Your inverse gets multiplied in front of your solutions. So I'm just going to go ahead and put my solutions right here, okay, because the inverse has to be first. Now this is a 2 by 2. This is a 2 by 1. The 2's match, so that means that you can multiply this. That's great, because that's what we have to do here. My solution is a 2 by 1, so I'd have x and y. So let's go ahead and multiply. 0 times 3 over 31 is 0. Plus, shift it over, shift it down. 5 over 31 times 31. I'm multiplying by the denominator, so the 31s would cancel, leaving you a 5. 0 plus 5 is 5. Now I go to the second row. 0 times 5 over 31 is 0, plus negative 2 over 31 times 31. Again, the 31 would cross cancel the 31, leaving you a negative 2. 0 plus negative 2 is negative 2. So these are your solutions. Your x is 5 and your y is negative 2. So you just solved a system of equations by writing a matrix equation, finding the inverse so you could multiply it to the other side, isolate your x, y to get your solutions. Let's do one more of those, guys. Okay, step one, you want to make a matrix equation. So you have to start off with your coefficients. The x's are lined up, the y's are lined up. The numbers in front of the variables are 1, 1. The second row, it's 2, 3. So that's your first matrix. That's your coefficient matrix. The variables that you are solving for is x, y. Equals your solutions, 4, 9. Now in order to solve for x, y, your variable matrix, you have to move this to the other side. The way you do that is you find the inverse. In order to find the inverse, you start off with the determinant. 1 times 3 is 3, minus 2 times 1 is 2. 3 minus 2 is 1. 1 over 1 is a 1. So 1 goes outside of, switch these two. Okay, these are the numbers on the main diagonal. They switch spots. So the 3 comes up here, the 1 goes here. The 1 and 2 stay, but they become opposite signs, so now they're both negative. If I distribute a 1 into everything, it won't change. Anything times a 1 keeps its identity. That's that multiplication identity property. This is the inverse. When I move the inverse to the other side, it has to come in front of your solutions. So the 4 over 9 has to come after the inverse. This is a 2 by 2. This is a 2 by 1. The 2's match. So that means my solution is going to be a 2 by 1. The top is going to be the x, the bottom is going to be the y. So let's go ahead and solve it. 3 times 4 is 12, plus negative 1 times 9 is negative 9. 12 plus a negative 9 is 3. Go to the second row, back to that column. Negative 2 times 4 is negative 8, plus 1 times 9 is 9. Negative 8 plus 9 is 1. So you guys, this is your solution. Your x is a 3, your y is a 1, and you are done. All you have left for today, because I knew that the notes would take a little bit of time, so for today, you want to look in your packet and you are doing your quick quiz. So it is just like one question of everything, just while it's fresh in your mind. Now tomorrow was supposed to be the day of caring. Those of you who were not here in previous years, foreign exchange students, what the day of caring is it was a day where we go out as a school and we help the community out by raking yards and washing windows and just helping them do some yard stuff now that it's spring and the weather is nice. So please, tomorrow, we are going to do WDC's Day of Caring Home Edition. Find something at home where you can help your parents, whether you sweep out the garage or you help wash some windows, help rake. Maybe there's a closet in the house that your mom really wants you to help organize. So tomorrow, please do Day of Caring. You don't have any math homework. Okay, tomorrow, go ahead and help do something at home. I am giving you points to send me an email and tell me what you did for your home edition of Day of Caring. I hope you guys liked inverses, and we will look at these a little bit more on Thursday. Take care. Bye.